Your deploy pipeline just failed with pathspec, did not match any file. The submodule commit doesn't exist on the remote because someone forgot to push it. Here's exactly why. Let's break down Git Submodules, managing nested repositories, how it works, and the exact mistake behind that failure. A submodule is just a commit pointer stored in the parent repo. When you add a submodule, Git creates a file called Gitmodules that maps the submodule's path to its remote URL. It also creates a special entry in the parent's index, a gitlink entry that records the submodule's current commit hash. When you commit, that hash is stored in the parent's commit object. When you clone, Git sees the git link, creates an empty directory at that path, and records that the submodule needs to be fetched. The actual checkout happens only when you run Git Submodule update. Use Git Submodule status to see the state of all submodules. The leading character tells you, means uninitialized, plus means modified, U means conflict. You can also inspect the gitlink entry directly with Git lstree. Adding a submodule is straightforward, but most people miss the critical step, pinning to a stable commit. Don't just add the default branch head that will break when the branch moves. Always specify a tag or a specific commit. Here's how to add a submodule for a shared config library. Notice we pin to a tag v210. After adding, commit the parent repo and push both the parent and the submodule if you own it. When you clone a repo with submodules, you get empty directories. Running Git Submodule update init recursive fetches and checks out the pinned commits. The recursive flag is essential for nested submodules. Always use init the first time. After that, Git Submodule update without init works, but if you're writing a script, always include init to be safe. For CI, you can use recurse submodules on clone. Submodules are always in a detached head state after Git Submodule update. That's by design. The parent controls the exact commit. But if you need to make changes inside a submodule, you must first check out a branch. The classic mistake: someone updates the submodule but forgets to update the parent pointer. To update a submodule, first run Git Submodule update remote to fetch the latest commit. Then commit the parent repo to record the new hash. Always push both the parent and the submodule if you made changes inside it. Submodule merge conflicts are a special kind of pain. When two branches change the submodule pointer to different commits, Git sees a conflict in the parent repo. You resolve it by choosing the correct commit hash. But if both branches changed files inside the submodule, you have to resolve conflicts inside the submodule repo itself. Here's how to handle a submodule merge conflict. First, check the conflicting hashes with git diff submodule. Then decide which commit to keep or merge the submodule branches manually. Always commit the parent after resolving. CI pipelines are where submodule misconfigurations become production incidents. The most common failure: the pipeline clones the parent repo, but the submodule commit doesn't exist on the remote. Here's a hardened CI script that catches these issues early. This CI script uses actions checkout with submodules, recursive, and a pat for private repos. It then verifies that each submodule commit exists on the remote using git ls-remote. If a commit is missing, the build fails immediately. Submodules are not the right tool for most dependency management. If you're sharing code within a single organization, consider a monorepo or a package manager. Submodules shine only when you need strict version pinning across independent repos that evolve on their own schedules. This is the same issue we highlighted at the start. Here's exactly why that happened. A developer updated the submodule pointer to a commit that existed only on their local branch. They pushed the parent repo, but forgot to push the submodule repo. The CI fetched the parent, saw the new hash, tried to check out that commit in the submodule, and failed because it didn't exist on the remote. The developer pushed the parent repo with a submodule pointer to a commit that only existed locally, forgetting to push the submodule repo. CI fetched the parent, tried to check out that commit in the submodule, and failed. The fix is to add a CI step that verifies each submodule commit exists on the remote using git ls-remote. If a commit is missing, fail the build immediately. Also, always push submodule changes before pushing the parent repo commit that references them. This is the exact mistake from the incident. The developer pushed the parent repo commit that updated the submodule pointer, but the submodule commit wasn't pushed to its remote. The CI then couldn't find that commit. Always push the submodule first, then the parent. If you make changes inside a submodule without first checking out a branch, you're in detached head. You can commit and push, but if you forget to update the parent pointer, the parent still references the old commit. Always check out a branch before making changes. Never add a submodule with bmaster or bmain. When someone pushes to that branch, your submodule pointer becomes stale, but the parent repo still references the old commit. You'll get a detached head in the submodule and confusion. Always pin to a tag or a specific commit hash. To prevent the common incident where a submodule commit is missing on the remote, add a pre-push hook that verifies all submodule commits exist upstream before allowing the parent push. This catches the mistake locally before it reaches CI. When using Git Submodule Update Remote, the Submodules branch is determined by the branch setting in Git Modules. If no branch is set, it defaults to the remote's head, which can change unexpectedly. Always explicitly set a branch in Git Modules to avoid surprises, e.g. git config, f Git Modules submodule, path, branch main. When a merge conflict occurs on a submodule pointer, you can resolve it by checking out the desired commit hash. This snippet shows how to accept the version from a specific branch and commit the resolution. Here are the first response commands for debugging submodule issues. Use Git Submodule status to see the state, Git ls remote to verify commits exist, Git diff submodule to see pointer changes, and Git Submodule sync to update URLs. Let's run through some common interview questions. How does Git store submodule references? Git stores a Git link entry with mode 160,000 in the parent's tree object. When to choose submodules over monorepo, use submodules for strict version pinning across independent repos, monorepo for tightly coupled services. How to resolve submodule merge conflicts. Manually choose a commit or merge submodule branches, then update parent pointer. And a few frequently asked questions. How to update all submodules. Run Git Submodule Update Remote recursive from parent root, then commit parent. Difference between Git Submodule Update and remote. Update checks out pinned hash. Remote fetches latest from remote branch. How to remove a submodule. Run Git Submodule Dainit fpath, Git rm fpath, commit and clean Git modules. To wrap up, remember that submodules are commit pointers, not file copies. Always push submodule changes before the parent commit that references them. Pin to tags, not branches. And if you find yourself updating submodules more than once a month, you're probably using the wrong tool. Ready to go deeper? Up next, Git internals, objects, trees, blobs, and the DAG, then conventional commits, standardized commit messages, then Git blame, find who changed what and when. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.